Hi, and welcome to this new video where I'm gonna talk about SNL, the new software by GeoStru for the analysis of slopes or excavations reinforced with soil nailing. Before starting, I remind you to join our YouTube channel to be always updated about our latest videos. We're now ready to start. This is the window shown after opening the software. I would like to point out that from the symbol of the question point, you can have access to the help online where you can find a detailed explanation about the commands of the software as well as the basic theory of the soil nailing and the verifications performed by the software. In addition, the software performs the verifications using the different approaches required by Eurocode 7. From this page, you can take a look at how the software employs this standard. Let's go back to the software, at the panel Home. From here, we can define the geotechnical model of the problem under examination and perform the analysis. In the bar located on the top of the window, we can define the archives of nails and soils to employ successively to ease the model creation. This button gives access to the soil archive. This table contains some soils included in the default archive of the software. The user can modify these soils or add new ones, simply by changing or filling in the cells of this table. For time reasons, in this tutorial we are going to refer to the default soils. After closing this archive, we can take a look at depth of the nails from the specific button. In this case, one type of default nail is included, but analogously to the previous case, we can change this typology or add new ones. Also in this case, we are going to refer to the default nail. After closing the archive, I would like to point out that the window on the left is split up in some panels, each of which allows to define a specific aspect of the problem. We can access these panels also from the specific buttons on the top bar. Let's start from the definition of the general data. At first, it's necessary to define the method for the calculation of the inclination of the failure surface. This value can be assigned manually from the user or calculated from the rankings theory as 45 degrees plus half of phi. In this example, let's assume a constant value equal to 60 degrees. I would like to point out that I'm talking about a plane failure surface to employ for performing the internal verification. You can find more details about the calculation method employed in the online help as I previously showed. In this section, we have to specify the length of the sliding surface where the verification against sliding will be performed. From this menu, we observe that we can choose between different methods to this purpose. In this example, we choose the automatic calculation, therefore we don't have obviously to specify any value in this field. Also in this case, more details about this verification can be found in the help online. The software allows performing the verification referring to static or pseudostatic conditions. In this latter case, we have to assign the values of the horizontal and vertical seismic coefficient and the point of application of the seismic thrust. Referring to this example, for the sake of simplicity, I'm going to perform the analysis in static conditions. Therefore, I will leave these values nil. From this menu, we choose the theory for the calculation of the thrust coefficient. Specifically, in this case, we refer to the Coulomb's method. From here, we can choose if the structure is permanent or temporary, and finally, the standards to refer to. In this case, we employ the Eurocode. Then, let's click on Apply and go on the next panel, Geometry. In this panel, we define the geometry of the wall and of the soil downstream and upstream the soil nailing. Specifically, the upstream part can be divided in two segments with different length and inclination. In this case, let's assume that the wall is characterized by a height of 5 meters, a thickness of 10 centimeters, and that it's perfectly vertical, therefore the inclination is nil. Let's suppose that the coating is made up of concrete, but we can account for the presence of an eventual net. Let's assign a length of 10 meters for the geometry downstream and anneal inclination, assuming that it's horizontal. Regarding the geometry upstream, let's suppose that the first segment is 10 meters long and 5-degree inclined, whereas the second segment is 5 meters long and horizontal. By clicking on Apply, the geometry is represented. Let's move now to the panel stratigraphy. From this panel, we have to define for any layer the thickness, the unit weight, the saturated unit weight, the angle of shearing resistance, the cohesion, the soil wall friction angle, that in this case should be equal to the angle of shearing resistance, and the soil nail interaction coefficient for the calculation of the pull-out resistance. This latter is automatically calculated by the software as a function of the angle of shearing resistance of the soil. If we employ the soils included in the archive, these latter values will be automatically uploaded from the archive. Otherwise, they will have to be input manually. In this case, let's suppose to have a first layer with a thickness of 2 meters and a second layer with a thickness of 3 meters. The sum of the first layers must be equal to the height of the wall. Let's suppose to have a further layer 5 meters thick. This latter is considered as the foundation soil and will be considered for the concerning verifications. In this case, let's assign for any layer the soils included in the archive. We note that the different fields are automatically filled in. Let's click on Apply to view the stratigraphy and move on the panel Groundwater. In this panel, from this voice we can define whether a groundwater level is present or not. In this case, it is. Therefore, we have to define the level measured from the ground surface. Let's suppose that this level is equal to 3 meters in this case. We can choose whether the wall is impermeable or not. In this case, let's suppose that it's impermeable, as the wall is made up of concrete. Finally, we can choose if the groundwater is unconfined or confined. Let's click on the button Apply and move on the panel Surcharges. The software allows to account for the presence of distributed loads from the first table, strip loads from the second table, and linear loads from the last table. In this case, let's suppose to apply a strip load at the distance of 3 meters from the wall and characterized by a length of 4 meters. The load can be permanent, variable, or exceptional. In this case, let's assume it's permanent. Finally, let's assign a magnitude equal to 10 kPa. By clicking on Apply, the load is visualized and it's possible to move on the definition of the nails from the specific panel. In this panel, it's necessary to define all that concerns the geometrical and mechanical characteristics of the nails. Referring to this example, let's suppose that the wall is reinforced with 5 nails with a vertical spacing constant and equal to 1 meter. The first nail is located at the depth of 50 centimeters, therefore the other ones will be placed at the depths indicating the following. Let's assign the typology previously defined in the archive to any nail. We note that many information has been automatically uploaded. It still remains to define the length and inclination of the nails. Let's assign in this case a length equal to 5 meters and an inclination equal to 10 degrees for any nail. It's worth noting that in this case the nails have constant length, spacing and inclination, but they can also be assigned differently for any nail. Moving from the bar on the right side, it remains to define the reduction coefficient for reinforcement thrust. Let's suppose it's 0.85 for any nails. Finally, it's necessary to assign the spacing of the nails in the horizontal direction in this field. Let's suppose it's equal to 1 meter. Let's click on Apply and the nails are consequently added to the model. We note that the excavation height has been automatically split up in 5 stages, one for any nail, delimited from the dotted lines. The calculation will be performed by accounting for the eventual excavation stages, assuming that in any stage one nail is realized. In case the soil nailing is not associated with an excavation, but for example simply to the reinforcement of an existing slope, the different excavation stages can be ignored in the results visualization and refer directly to the final stage. At this point, it's possible to move on the calculation from the specific panel. At first, in this panel it's necessary to define the coefficients required to employ the standard approach. The software refers to the combination A1, M1, L3. However, the user can choose to refer to another approach just by changing the specific coefficients. All the concerned indication is provided in the help online at the page dedicated to the standards. Finally, from here we can assign the correlation factor of the number of investigation profiles required by the standards for the calculation of the pull-out resistance. After assigning all the required values, it's possible to click on Apply to make the changes effective and then perform calculation. We note that at this point a new panel appeared dedicated to the menu Obtain Results. First, from this menu, it's possible to choose the excavation stage referring to which we would like to check the results. By zooming on the geometry, we observe the plane failure surface employed for the calculation of the active thrust and for the execution of the internal verifications, whereas on any nail, the absorbed force is indicated. On the wall, the factor of safety against the internal verification is indicated, whereas on the right side of the model, for any nail, the results of the failure and pull-out verifications, as well as the effective length, are indicated. On the left side of the window, the active thrust coefficients are indicated along with the effective, total, and water pressures, besides the diagrams of shear force and bending moment. By clicking on the panel output in the top bar, it's possible to obtain more details concerning the calculation results by generating the report from the specific button. In the first part, the report indicates some theoretical concepts that the software is based upon, the employed theories, and the standards. Successively, the obtained results are plotted numerically. At this point, let's go back to the software and complete the calculation by checking the global stability. To this purpose, the software can interact with the GeoStru software slope from the specific button. We note that our model has been imported in slope and it's now possible to proceed with the calculation from the panel computation. For more details about how to use the software slope, you can take a look at our video specifically dedicated to this software by clicking on the concerning link indicated in the description. At this point, I showed you the main features of our new software for the analysis of soil nailing. Before wishing you a good work using this software for your cases, I remind you to push the like button on this video. Bye!